So this is part one of phenols, and in this we are going to study about the classification of phenols. First thing, the definition of phenols. In definition of phenols, we are having like phenols are hydroxy derivatives of the aryl groups, right? They are hydroxy derivatives of the aryl group. So what is hydroxy derivative? Hydroxy meaning OH, okay, and we have attached it to the phenyl ring. So phenyl plus the alcohol derivative will become what? Phenol. And what is this? This is the aromatic ring or aryl group. Aromatic ring minus one hydrogen is aryl. Okay, aromatic ring, any aromatic ring minus one hydrogen is aryl. So aryl alcohols, this comes under the class of aryl alcohols. To be specific, which alcohol it is? It is phenyl alcohol. Phenyl alcohol, and the name, exact name of this compound is phenol. So the classification of phenols will be monohydric phenols. Monohydric phenol meaning, obviously mono, you must have guessed it by now, that mono is one and hydric is OH. So the phenols which are having just one OH will come under this class. They will fall under this class, that is phenols, or we have cresol, right? So these compounds are falling under the monohydric category, monohydric phenols. Then after monohydric we are having the dihydric phenols. In these dihydric phenols we are having, have a look, two OH groups. So if I have the OH groups on the opposite sides, right, if I have the OH groups on the opposite sides, then it is called as quinol. Okay, then it is called as what? Quinol. Okay, the same quinol is a the derivative of a quinol is used in the famous medicine which was used in the first wave of corona, that is hydroxychloroquine, which is actually an anti-malarial drug. So quin is coming from that quinine ring. Quinine ring is coming from quinol. Okay, so this is a dihydric phenol. Then some more examples of dihydric phenol will be resorcinol, catechol. Okay, so if you are having OH groups on the opposite side like this, it's quinol. If OH groups are adjacent, it's catechol. And if you are having OH groups on alternate positions, consecutive alternate positions, that means one OH over here, and you leave one carbon, one position over here, and attach the second OH over here. You can also attach the second OH over here also, no problem. So this will become what? Resorcinol. Okay, what does it become? Resorcinol. Quinol, catechol, resorcinol. These are the three dihydric alcohols. Then after dihydric, we are having the next category, which is trihydric phenol. Now, needless to say that trihydric phenols will be having three OH groups in them. Now, when we are having three OH groups in trihydric phenol, it will look something like this. And names of these can be written as, okay, this can also be called as Benz 1, 2, 3. Benz is coming from, not from Mercedes Benz, it is benzene ka Benz. Okay, so 1, 2, 3, Benz 1, 2, 3 triol. Okay, Benz 1, 2, 3 triol, and name of this compound will be pyrogalol. Right, pyrogalol is the one which is used for dissolving oxygen. This is a compound which is known to dissolve oxygen. Another trihydric phenol here in front of you is fluoroglucinol, which is having Benz 135 triol. What it will have? Benz 135 triol. Okay, which is also called as fluoroglucinol. Okay, fluoroglucinol. So Benz 1, 2, 3 triol and fluoroglucinol. This is what? The examples of trihydric phenol. Here we are done with the classification of phenol. Right, what have we done with classification of phenol? Quickly we'll jump to the preparation of phenols. Okay, now preparation of phenols is very interesting, right, because you are having 4 to 5 methods in which we can prepare phenols, and we have made mnemonics for almost each and every reaction. So the first one will be from cumene. Now what is cumene? Cumene is isopropyl benzene. Yeah, what is cumene? Cumene is isopropyl benzene. Now in this structure we will be drawing, first of all, benzene ring. Remove one hydrogen, it becomes phenyl, but still we call it as benzene, isopropyl benzene, because it is derived from a benzene ring. Now have a look at this. This is not isopropyl benzene, by the way. I just wanted to show you. So this is propyl benzene. Okay. Only when you attach the phenyl ring to the second carbon, then only we can call it as isopropyl propyl benzene. Yeah, this is isopropyl benzene. Remember, iso comes when your second carbon. This is your first carbon, second carbon, third carbon. Second carbon is directly connected to one, two, three other carbons. Then we can use the word iso, right? That's why it is isopropyl benzene, also called as cumene. Cumene, I mean, the preparation of phenol from cumene is the commercial method. Okay, what it is? The commercial method for preparation of phenol from benzene, and this is our mnemonic. Okay, somewhat like cook, not exactly cook, but the spelling is COOC. This will help you remember the reaction. Commercial method of preparation of from phenols or for phenols. Okay, commercial method of preparation of phenols using cumene is cook. So C will stand for cumene, O will stand for oxygen. Okay, then the O and O single bond, right? O and O single bond together will stand for peroxide. Okay, O single bond, O is peroxide, and the last C is our catalyst, that is cobalt naphthenate. Okay, cobalt naphthenate. So this cobalt naphthenate is going to be our catalyst. Let us start the reaction. Just have a look at how I am writing the आइसोप्रोपाइल बेंजीन. सी आइसोप्रोपाइल बेंजीन पहले मैंने क्या किया था, CH3 लेफ्ट पे लिखा था, लेकिन अभी ऊपर लिख रहा हूँ. क्यों? उसकी एक वजह है. राइट वाला CH3 ऊपर ले रहा हूँ, और हियर वी हैड CH3 CH CH3 CH. let us write it over here. there is a reason for why we are doing it like that. we are writing it like that. okay, क्योंकि ऑक्सीजन ऐड करना है. ऑक्सीजन कहाँ पे ऐड करना है? कार्बन और हाइड्रोजन के बीच में. तो ये जो ऑक्सीजन है O2, उसको हम लोग ऐसे भी लिख सकते हैं O डबल बॉन्ड O. तो O डबल बॉन्ड O को कार्बन और हाइड्रोजन के बीच में फिट करना है. तो जब हम लोग कार्बन और हाइड्रोजन के बीच में इसको फिट करेंगे, तो व्हाट वी विल गेट, वी विल बी गेटिंग समथिंग लाइक दिस. दिस इज योर CCH3. जस्ट कॉपी पेस्ट, नकल करने में अकल चाहिए, नहीं तो शक्ल बिगड़ जाती. कार्बन और हाइड्रोजन में ये दो ऑक्सीजन को अटैच कर दो. सो जब दो ऑक्सीजन को अटैच करेंगे तो उनका डबल बॉन्ड क्या हो जाएगा? उनका डबल बॉन्ड सिंगल बॉन्ड हो जाएगा. राइट, इट विल बिकम एज, इट विल कन्वर्ट इनटू सिंगल बॉन्ड. सो दिस इज क्यूमीन हाइड्रोजन पेरोक्साइड. ऑन वन साइड यू आर हैविंग क्यूमीन, ऑन द अदर साइड यू आर हैविंग हाइड्रोजन, एंड दिस पार्ट इज पेरोक्साइड. क्यूमीन हाइड्रोजन पेरोक्साइड, क्यूमीन हाइड्रोजन पेरोक्साइड. ओके, क्यूमीन हाइड्रोजन पेरोक्साइड. तो अब ये इधर क्या करना है इसके बाद में, हियर वी विल बी एडिंग, हमारा कैटलिस्ट इधर ही यूज होगा, कोबाल्ट नाफ्थेनेट. ओके, कोबाल्ट नाफ्थेनेट. देन वी विल ऐड H2SO4 ओवर हियर. H2SO4 ऐड करने की वजह से क्या होगा, दिस OH, अब ध्यान देना यहां पर कि दिस OH will get attached to the benzene ring, to the phenyl ring, and this part will get eliminated. What is this? This is CH3C. Below CH3, copy paste CH3C, single bond O will become double bond O, and upper wala CH3 will remain as it is. So this becomes acetone. Acetone is nothing but propan 2-one. What it is? Propan 2-one. Okay, acetone or propan 2-one. All right. This is the byproduct, and this OH will get attached to the phenyl ring now and will become phenol, and that's what we wanted to prepare. So this is the first method for preparation of phenol, and it's also known as the commercial method. This acetone is volatile, it can easily be separated from phenol. So this is the first method for preparation of phenol. Now if you want to have a look at it, here it is. Right, so after preparing phenol, we are moving on to the second method of preparation, and in the second method of preparation we are having from aniline. Okay, from aniline. Okay, yes, children sitting here, please keep quiet, please keep your mouth shut. Recording में disturb होता है, ध्यान दो यहाँ पे. From aniline. Okay, so aniline is what? NH2. Okay, aminobenzene is also called as aniline, from aniline. Now in aniline, what are we supposed to do? We are going to form, I mean we are going to use something called as the Sand-Meyers reaction, right? जो पहले हम लोग ने Sand-Meyers में किया था, जो haloarenes में use किया था, right? The same thing we are going to use over here. So what are we going to use? S for sodium nitrite. Okay, sodium nitrite. Then AN stands for aniline, D stands for diazonium. तो यही फॉलो करना है हमको. क्या ऐड करना है? Na2 ऐड करना है. Na2 इज व्हाट? सोडियम नाइट्राइट इन प्रेजेंस ऑफ व्हाट? HCl. सो ये दोनों में क्या होने वाला है? इन situ रिएक्शन होने वाला है. यू ऑल नो दैट Na2 एंड HCl, will combine with each other or react with each other to form NaCl plus HNO2. और ये जो HNO2 है, this is our main hero, right? यही इन सीटू रिएक्शन का मेजर प्रोडक्ट है और इस इन सीटू रिएक्शन में से ही HNO2 जो मिलेगा वो इसके साथ में रिएक्ट करेगा। अब ध्यान देना कि यहाँ पे ये HNO2 जो रिएक्ट कर रहा है किसके साथ में, एनिलीन के साथ में। तो HNO2 जो रिएक्ट कर रहा है दैट इज ऑब्टेन्ड फ्रॉम द रिएक्शन बिटवीन दिस इन सिटू रिएक्शन एंड यू मस्ट बी हैविंग अ क्वेश्चन इन योर माइंड कि व्हाई हैव वी नॉट एडेड इट डायरेक्टली। रिमेंबर दैट HNO2 ये नाइट्रिक एसिड का छोटा भाई नाइट्रस एसिड है और वो गैस है। तो गैस को स्टोर करना ऐड करना मुश्किल है। जैसे कि हमको समझो कभी H2S गैस लगता है तो H2S गैस के लिए हम लोग क्या करेंगे, वी विल ऐड FeS iron sulfide plus H2SO4, dilute H2SO4, it will give you H2S. H2S, FeSO4, right? But H2S you will get as a gas when you react this. So if you want a H2S, we react these two compounds. We don't store H2S as a gas. Similarly, if you want HNO2, we don't store HNO2 as a gas. We take NaNO2 and HCl, we automatically get HNO2. So ये nitrous acid है. Nitrous acid and this nitrogen, both of them will react with each other, forming a disonium compound, right? Forming a disonium compound. Disonium is our magic compound, right? The nitrogens and nitrogens will react with each other, forming N triple bond N. What will it form? N triple bond N. Okay, it is going to form N triple bond N. So this nitrogen will gain a positive charge. Why? Because it is undergoing over bonding. Nitrogen की valency कितनी 3. So this nitrogen is satisfied 1 2 3, but it is having 1 2 3 4. That means this the left wala nitrogen, the first nitrogen, has donated his lone pair of electrons, and due to which the positive charge will get attracted to a negative Cl, and that's what we get over here, disonium chloride. I call disonium chloride as the magic compound. Why do I call it as the magic compound? क्योंकि इसमें आप जो कुछ भी ऐड करोगे वैसे वैसे प्रोडक्ट्स आपको मिलते जाएंगे, right? So say for example you add in this you add KCN, you'll get cyanobenzene. If you add HBF4, you'll get fluorobenzene. If you add H3PO4, you'll get only benzene. Cu2Cl2 chlorobenzene, Cu2Br2 bromobenzene, Ki iodobenzene, then HNO3 nitrobenzene, H2O if you add, which we are going to do right now. H2O if you add, you'll get phenol, and H2SO4 if you add, you'll get benzene sulfonic acid. So here I have named around 9 different products which can be obtained from this disonium compound or the magic compound. Why do I call it as the magic compound? क्योंकि ये बॉन्ड टूटने ही वाला है। क्यों टूटने वाला है? नाइट्रोजन का जो नेटिव स्टेट है N ट्रिपल बॉन्ड N, इट वुड लव टू स्टे इन इट्स नेटिव स्टेट। ये एक्स्ट्रा जो बॉन्ड है वो तोड़ने ही वाला है, ये जगह खाली होने ही वाली। तो आप यहाँ पे जो ऐड करोगे वो यहाँ पर तुरंत आके अटैच हो जाएगा। से फॉर एग्जाम्पल यू ऐड वाटर, so you will get what? Water will split into H plus and OH minus, and you will get OH attached over here, and that is what is phenol. So this is the second method by using disonium chloride or by using aniline, we have prepared a what? Phenol.